Hey YouTube, welcome back. Today our 10th video or ninth video, I don't remember, of our series of design a key value store. Today we will talk about how to handle the permanent failures. In the last episode, in the previous episode, we talked about how to handle the temporary episode and how the gossip protocol is a good solution to handle the temporary failures to handle the temporary failures. Today we are going to talk about the permanent failures and what a permanent failures look like. So let's just say that say that we have some sort of inconsistency or in a permanent inconsistency or permanent failure. So we use something called an entropy protocol, and specifically the anti-entropy protocol is a technique that is used in distributed system to ensure data consistency and integrity by practically reconciling differences between replicas or nodes. It's primarily employed in scenarios where replicas may become inconsistent due to network partitions or maybe node failures or delay in data synchronization. In the serial system, data replicate is commonly used to maintain multiple copies of data across different nodes or replicates. And to help to help ourselves to implement that, we use the entropy involves comparing each piece of data on replica and updating each replica to the newest version. So we use something, we use a tree, something called a Merkle tree to do this functionality. And a Merkle tree, also known as a hash tree, is a binary tree data structure that is used to efficiently and securely verify the integrity and the consistency of large set of data. And in the Merkle tree, the data is organized in hierarchical structure where each leaf node represents a block of data or a hash value of the underlying data. The non-leaf nodes, also known as internal nodes, store the hash value of their child nodes. And the root node of the tree, often called the miracle root, contains the hash value of the entire set data. And let's talk about how this works. So let's just take this an example. So let's say that we have two servers, okay, and we has let's assume that we have a key space from 1 to 12, and we have key space from 1 to 12, and in the and as we can see right now. And as you can see, we have something here. We have some sort of inconsistency in the key number 8, because in server 1 these two things are replicas. We have 8, and we have in this one we have nothing. So we have inconsistency, and this is permanent inconsistency. So how can we detect them first? After that, let's see how we can solve it. So in how we can detect it, we use a Merkle tree. So let's just build a Merkle tree together. So we have these two servers, and we have these keys. And first of all, we try to hash the keys, okay? And we try to hash the keys. You make sure that each key, you hash the key with 4 numbers or whatever it will be, and you will just make sure that key number 8 have hash and the other one is empty, okay? And when you continue doing that, we create right now, these are the, we can call them leaf nodes, okay? These are the leaf nodes. And after that, we create we create a single hash node per bucket. That's it. This is a bucket, and this is a bucket, and this is a bucket, and this is a bucket. We have 4 buckets right now. So we create a single node for each bucket. okay, and you just make sure you just see this bucket is hashed different because it's hashed based on its content that it has from its child. So you see that we have changes in the hash, and you continue actually doing that. We build the tree up until we reach the root, okay, and you see that now we have two servers and we have two different nodes, nodes basically, and we have two different hash. And when we compare these two Merkle trees, started by the comparing the root hashes, if root hashes match both servers, like if this root matches this root, that means both of them have the same data. If root hashes disagree, then the left child hashes are compared to the other left child, and the right child also are compared. And by this way, we could know we could have the ability to know how we detect where is the inconsistency live basically. So how this that will work? So we will make some sort of, we can, you can think that we can do like a depth first. So first of all, are these equals to each other? No. Okay, so let's just go to the left side. Is this root equals to this root? Yes. Okay, the left side is done. Let's go to the right side. Is the right side equal the right side? No. Okay, so let's see where is the problem basically. So I'll say, okay, if the right side equal the right side of this one, yes, okay, so the problem is in the left. So let's talk about the left, and you just to continue to compare until you reach this specific node. And using the Merkle tree is the amount of data needed to be synchronized is proportional to the difference between the two replicas, and it's basically, this is how you can solve this problem effectively. And that's it for today's video. I hope my solution was quite good, and see you in future videos.